Hey, eighth grade, welcome to our flip lesson on velocity and acceleration. So this is the end of lesson 2 and the beginning of lesson 3. So if you want to follow along in your textbook, it starts on page 12 with the end of lesson 2 and then continues on to page 17, which is lesson 3. So today, my dog, she followed me up here. There's Lucy. Hey Lucy, want to say hi? Yes. So instead of hearing her bark, maybe I can keep her in here and she won't bug us so much. So I've confiscated Jason's room for some of my recordings. See, you go to college, your room gets used for other things. So let's begin. We'll start with velocity. So I don't know, I'm a big Despicable Me fan. So Vector, the villain on Despicable Me, has this great scene when he's meeting Gru and he's trying to explain what he's all about. And he says, "My name's Vector, that's me, because I commit crimes with both direction and magnitude." I love that little science joke because it does give you a very good definition of what velocity is. So velocity is a vector quantity. And pretty much what that means is that a vector quantity is a value, which is a number in a given direction. So you might see a vector value come with an arrow pointing in some direction. For our purposes, velocity is basically speed in a given direction. So you know how to calculate speed. That's just distance divided by time. With velocity, you want to give a direction. And this is actually really useful. And when you hear things, moving in certain directions, you are really hearing velocities given to you. A great example of this is storms coming in. So storm comes in and the weatherman says the storm is moving 25 kilometers per hour. Well, that's all fine and good, but that doesn't really tell you if you should get out of the way of the storm. So 25 miles per hour southeast, all of that lets you know if your home is in the path. You're also really happy that your air traffic controller knows velocities because he is controlling airplanes and the direction of airplanes. So for an air traffic controller to just know that a plane is moving 400 miles per hour, that is useless information for him without that direction. So is it 400 miles per hour north, east, south, and west? That would be a velocity. So the calculation does not change, but if you see something in a given direction, that is the velocity, not the speed. So velocity is just speed with that vector quantity in a given direction. This is important information because the very next lesson we're going to be working on is acceleration, and acceleration is defined as a change in velocity. Now, it's specifically not a change in speed, it's a change in velocity because there are three ways that you can change that an object can accelerate. And I say up there in science because if I were just to ask you, define acceleration, you would probably say, give me an example of speeding up or running a race and finishing, a really fast last 400 of your race, you were speeding up. So we tend to think of acceleration as moving faster, when in science, it's any change in velocity. And since velocity is speed and direction, acceleration is any change in speed or any change in direction. So acceleration, you could be increasing speed, and this is the one that you will recognize most easily. If an object is going faster, you would say that that object is accelerating. But also if an object is decreasing speed, you might say that that's deceleration. You will also in physics hear that called negative acceleration. So any acceleration that is slowing down when you are solving for that will be a negative number. That shows you that the object is decelerating, is slowing down. Now, deceleration is also considered an acceleration in science. I would just get into the habit of not using the word deceleration. Any change in speed, whether you're increasing or decreasing, is acceleration. But to add to that, you are also accelerating if you're changing your direction. So if your car was going a constant speed of 40 miles per hour down a straight road, and you were never changing speed, so at 40 miles per hour straight road, and then the road curves, even though you're still going 40 miles per hour, you are accelerating. And why you're accelerating is because your direction has changed. So that's where acceleration gets a little bit fuzzy, because something could be moving at a constant speed and still accelerating if its direction is changing. A really good example of this, and we'll talk about this, is centripetal acceleration, and these are objects that are moving in a circle. If something like this Ferris wheel is moving 5 meters per second, that number, 5 meters per second, tells you that it's moving at a constant speed. The Ferris wheel is constantly accelerating, even though it's not ever going any faster. Okay, that would be kind of scary. But because it is moving in the circular direction, the direction is constantly changing. So even though it's going 5 meters per second, its acceleration is constantly changing. I know that that can be a little bit confusing, and so all week we're going to be working on problems and activities to help us with this. Basically, just get into the habit of any change in velocity, whether you're increasing, decreasing, or changing direction, is a change in acceleration. The object is accelerating. So how do we calculate acceleration? Well, it describes the rate at which velocity changes, and if the object is not changing direction, then acceleration can simply be considered the rate in which speed changes. So this is the opposite of what I said before. So if you're going down that straight road at 40 miles per hour, and you're at a constant speed, but the direction changes, you are accelerating. You can also be accelerating if the road stays straight, but you keep changing speeds. That is accelerating. The road, you're going 40 miles per hour and someone cuts in front of you and you slow to 20 miles per hour. You're still accelerating. If the road is going straight, you're going 40 miles per hour and you think, hey, no cops. You start going 50 miles per hour. You are accelerating. So how do you solve for that? Simple equation. Acceleration equals your final velocity minus your initial velocity divided by the time it takes you to change velocities. Now remember, slide before, we defined acceleration as a rate in which velocity changes. So we need to know what the change in your velocity is. It's not as simple as just a distance divided by time. We need a change in your velocity over a certain period of time. And so this equation, generally you'll be given a problem and it will say an object is moving at this speed or velocity and then this one, and it took this amount of time to change that speed. What's the acceleration? Now in this equation, if your acceleration is going to be negative, then your final velocity is going to be less than your initial velocity. When you subtract those numbers, you get a negative number divided by the time, and we'll work on some of those. The units for acceleration are meters per second squared, and you can kind of see that in the formula up there. Meters per second minus meters per second divided by seconds is going to give you meters per second squared. Now sometimes you're not really used to using these equations, you'll be tempted to like square your final number. Just take a look at this equation and just go with what you know in mathematics and units. Meters per second minus meters per second divided by seconds is meters per second squared. You don't square your answer. The units are squared in the equation. Your answer is not squared. So let's practice a couple of problems. So a roller coaster is rapidly picking up speed as it rolls down a slope. As it starts down the slope, its speed is 4 meters per second. Okay? 4 meters per second. But 3 seconds later at the bottom of the slope, its speed is 22 meters per second. What is the average acceleration? So ask yourself, what is my final velocity? Final velocity is at the end of the acceleration. What's the velocity? In this equation, the final velocity, it says 3 seconds later, the velocity was 22 meters per second. So 22 meters per second, what is the initial velocity? At the beginning of the slope was 4 meters per second. Okay? And what was the time it took to change? 3 seconds. So 22 meters per second minus 4 meters per second divided by 3 seconds. 22 minus 4 divided by 3 is 1.8 meters per second squared. Whoa, I don't know what happened there. Let's undo that. There we go. And so as your roller coaster is picking up speed, it is picking up speed at a rate of 1.8 meters per second. Every second, it is increasing its acceleration at this rate. Next, and don't worry, these are just a couple of easy practice problems. We will be working on a lot of problems during the week. A lizard accelerates from 2 meters per second to 10 meters per second in 4 seconds. What is the lizard's average acceleration? Okay, so its final velocity is what? So from 2 meters per second to 10 meters per second. So 10 meters per second was its final, minus 2 meters per second, divided by the total time it took to accelerate, which was 4 seconds. That is 2 meters per second squared. What that number is telling you is that during this 4-second time period, it was accelerating at a rate of 2 meters per second. So every second, it was accelerating 2 meters. Hope this helps get you started on the week. This week we'll do practice problems. You'll set up some lab activities to observe acceleration and measure acceleration, and get to talk to your lab partners about what this all means.